Hello everyone. Last time we talked what kNN is and how kNN works, but today we're implementing it. And to implement kNN, I've listed 5 major steps which we mostly follow for almost all machine learning algorithms. And first things first, we need to import our data. But for that, I need to have some code cells, right? And we're using IRIS dataset, a super simple dataset, and it's found in Scikit library under datasets module. So let's import it. So let's print the type of iris. We see that this is a bunch data type, which is almost similar to dictionary data type in the sense that it has keys and values. So if I am to print the keys, so we see that we have several keys. So why not to print some values as well? Let's see the feature names, all right? Okay, so we have 4 features: sepal length, sepal width, petal length, and petal width. So what about target names? Okay, I'm accessing iris dataset. Okay, so we have 3 classes, right? All right, so we need more code cells. All right, so we saw that we have 4 features and we have 3 categories of flowers, right? To see the description of data set, let's call this E. And it looks like it gives us the summary of our data set. So we can see that we have 150 number of instances, which are also called samples in machine learning. And we have 4 attributes. We saw that. And we have 3 classes. And here is a tabular summary of our features, right? All right. So lastly, quickly, let's see what is the dimension of our features and of our target. All right. So if I'm to see iris feature, sorry, data dot shape. All right, so we have 150 samples and we have 4 features, right? So this is a 2D array with this shape. And similarly for our target, we see that it's a one-dimensional array which with 150 samples. So with this, we loaded our data and then we quickly saw how the data looks like, right? So let's move to the other step, which is splitting our data set into train set and test set. Before we actually split our data set into train set and test set, let's take a moment to discuss why we're doing this split. So what happens in machine learning is we use training data to train the model. And then when we are done training a model, then we want to evaluate it. So to evaluate the model, we need to feed the data which the model has never seen before. That's why what we do is we separate a chunk of data initially from the original data set, which is called test data set, and then keep it for the purpose of testing the model. So we will be doing that split now. And thanks to Scikit because it has created one function named train test split, which has made our lives so easy. So without any doubt, let's import that. Right, it just recommended me the whole code. So this function train test split basically shuffles our whole data set and then splits into training set and a testing set. And if we are to talk a little bit about what parameter this function takes, so the first parameter is always the feature, right? And the second parameter is the target. And the third parameter that we're giving here is the test size, which is like 20% I want to be on a testing set, and the rest 80% I want to be on a training set. And then this random state is because we want to regenerate the same training set and testing set each time we run this notebook. So let's run this cell. And let's quickly print the shape of all the outputs. Here we can see that 120 samples went into the training set and the rest 30 samples went into the test set. So with this, we successfully had a split among train set and test set. All right. So let's go into the EDA section where we will look a little deep into what our data actually looks like. Before you build your data, it's always a best idea to explore your data. Personally, I like to use this amazing library, Y-Data Profiling, because it generates detailed reports with visualizations and also points out some potential data issues. So we will do the same here. So let's import it. I think import profile report. But there is a caveat on this. We need to first change our xtrain into a pandas data frame. All right. Let's change. Xtrain columns was features name, right? And then we'll be using the same data frame into here. And let's see what the report looks like. Well, it takes a little time here. Okay, so we have a very detailed report here. And then it basically says everything. So we have 4 variables. We have 120 observation because this is a training set, and we don't have any missing cells. We have 1 duplicate row, and it takes 3.9 kilobytes in memory. And this also gives us this distribution histogram plot for each feature. So this is our sepal length, one of the features, and it has 34 distinct values, no missing values. The mean value is this. Similarly, we can see for each of our features and including some interaction plots as well. So yeah, this is super informative. Also, we have heat maps, right? So we can see how features are correlated as well. And on top of this report, it doesn't hurt to have some pairwise plots between features, and especially if color coded by the class. By class here means by species of flowers. Okay, so let's import Seaburn. The reason that I'm importing Seaburn is because it generates really nice plots, which we can see in a while. And let's add target column into our iris. Oh, sorry, it's data frame, not data. Equals data column. And then let's do a pair plot. All right. Pair frame. And the diagram kind is hist. Let's see. All right, this is the pairwise plot. So the blue dots are of Serosa category, and the orange ones are versicolor, and the green one is virginica. All right, and we have features on both x-axis and y-axis, and you can see the interaction between features. All right, so we see that this, if we see this specific plot, we can see that we're able to distinguish the categories easily here, right? When we take sepal length and petal width. So this means that we should be able to build a machine learning model which can classify them accurately. This gives us one level of confidence. All right. With all this, now we are ready to build our model. And if you remember last time, we were discussing applications of kNN, and then we mentioned several times that kNN is suitable and mostly prevalent in the cases where data set is simple and straightforward. And we're using IRIS dataset, which is one of the simplest datasets available. So kNN is the great choice in this dataset. So let me create some code cells again. And as usual, we'll be importing kNearest classifier from Scikit. Okay, so from Scikit, here it is, and then we will create one classifier object. So we have to specify the number of neighbors we want to consider when classifying a new data set. All right, so for this case, let's put it 1, as the data is simply straightforward. Oh, this is equals. So with this, we've created our kNN object, and this encapsulates the algorithm that will be used to build the model from the training data, as well as the algorithm to make predictions on the new data points. All right, but if you think, then there is a question like, why is fitting necessary in kNN? Because kNN is basically a lazy algorithm, right? So it doesn't do anything. It's not like we are learning weights or biases when we are training the model. We're basically doing nothing, because when a new data set comes, then we are only calculating the distance between a new data point and all the existing data points, and then considering the nearest neighbor and seeing which class the nearest neighbor falls. And on the basis of that, we are also classifying the new data point to the same class, right? So that's why there is nothing like we are training the model. But still, we have to call a fit method, because we have to let kNN object know all the data points that we have. All right, so for that matter, we will call our kNN fit xtrain. We'll give the training data. So all right, so after this, our model is ready. So now we can use this kNN object to predict a new data point. Now we can use this kNN classifier to classify a new sample. Say we found a flower and we took the 4 measurements which we need to give to this classifier, and then we will get a target, right? So let's do it. But before that, I need to see what is the order of the features. All right, so we have sepal length first, and sepal width, then after petal length, and lastly we have petal width, right? Okay, so let's create one new sample. Okay, new sample is, we should create a 2D array. So let's say that sepal length is 5 and sepal width is 2.8, and then petal length is 2 and petal width is 4. Okay, no, 4 is, I think, a little too much, because I see the values are fairly less, 0.3. Okay, so this is our new sample. Oh, sorry, numpy is not imported. So before that, let's import numpy. So let's predict. Let's keep it under the prediction variable. Predict, and okay, so we have to also see what the prediction came out. Okay, so print we want to see the name, right? Okay, so this one. Okay, so this is Setosa. So our model predicted that the new sample that we gave is under the Setosa category. But how do we make sure that what it is giving is something that we can believe? And for that, we need to evaluate our model. So we will be doing that next. So if you remember last time when we separated our data into train set and test set, we haven't touched test set yet, right? So we will be using that test set to evaluate our model. So let's quickly do this. So we will find the predictions for the test set. So these are the predicted labels for the flowers in the test set, and also we have the actual labels, right? So we will be comparing the predictions with actuals. Okay, let's see what the predictions are. These are the predictions, and finally, if we want to score, okay. Okay, so the test cell score is 100%, so that means our accuracy is 100% because this NP dot mean, this is basically calculating the accuracy. So the total number of correct predictions divided by the total number of predictions, right? So with this, we sort of saw that our model is performing extremely well because we have predicted all test set correctly. We evaluated our model also, and congrats to us because we implemented kNN as a classifier. So what did we achieve here? We used IRIS dataset to build a supervised machine learning model that predicts the species of a flower based on its measurements. Along the way, we explored our data, we visualized it, and also we evaluated the model's performance. Though IRIS dataset may be simple, but it's a great starting point for understanding the basics of supervised learning. And with this, I'll see you in the next video. Bye.